This is 2.4 linear inequalities. We're going to be sketching graphs of different inequalities, solving linear inequalities, and then do a little bit of application problems. So when we talk about x equals 7 is a solution, that means on our number line, at point 7, you're just going to have a dot, right? But an inequality, one involving the less than, greater than, less than or equal to, or greater than or equal to, isn't just one point. Okay, the only solution for an equal is 7. But this is saying the solutions are those numbers greater than 7. So that could be 7, that could be 8, 9, 10, that could be 100. So how do I represent all of those different numbers? I'm not going to put dots on every single solution. So what I'm going to do is draw an arrow showing that it's everything bigger than 7. Now I did an open circle because one of the solutions is not 7. It says the solution's got to be greater than. So that could be 7.1, but it can't be 7 because 7 is not greater than 7. Okay, so we're going to be working with inequalities such as this. So we have what's called bounded intervals on the number line. And A and B are just numbers that we call endpoints. They're what bounds our number line solution. So for instance, here, this wasn't bounded by anything. It kept going. Bounded means it stops. So a bracket, such as these square brackets, indicates that the endpoint is going to be included. Okay, the A and B is included as a solution. A bracket is the same as a closed dot on a number line. Okay, then we have parentheses. Parentheses indicates that the endpoint is excluded or not included. And parentheses are the same as an open circle on a number line. Okay, so there's different ways of doing it on WebAssign. You can either use brackets or you can either use parentheses. But let's look what I'm talking about. If A and B's are numbers and it has brackets, this solution is a closed solution because it's bounded. Okay, so the solutions to this notation or to this interval, the solutions to this interval are going to be bigger than or equal to the number A, okay, but also less than or equal to the number B. So the solutions are somewhere in between A and B, and it can equal A and it can equal B. So that's why we do an or equal to. So the graph of this would look something similar to at point A and at point B, we're going to be bounded. So we're going to use either brackets or you could use a closed dot to show that all your solutions are in between these numbers A and B. Okay, so the other thing you could do is a dot, and a line, and a dot. Those two graphs mean the same thing. The next one is an open interval, okay, because we're using parentheses. So remember, these brackets mean that the endpoint is included. A and B could be solutions, but the parentheses mean that the endpoints A and B are excluded. So our solutions are bigger than A, numbers bigger than A, but numbers less than B, but it can't be A or B. So on your number line, at A and B, you can either use parentheses to show that A isn't a solution or B isn't a solution, but the numbers in between are, so we're going to highlight those numbers in between, or you can use an open circle at A and B, connecting them to show that the solutions are in between A and B, but not including A and B. All right, and the next one, it's half closed and half open. So what's that inequality look like? Well, this bracket means that A can be a solution, so we want the or equal to. So we want X bigger than A, but we want X less than B. It's a parenthesis, so I just want the less than. B isn't a solution. So we need to be careful about when we see brackets and when we see parentheses because they mean different things. So on our number line, I want to include A as a solution, exclude B as a solution, and I want all the numbers in between. Okay, so notice how bounded intervals are always going to be in between. So a bracket is the same as a closed dot, and a parenthesis is the same as an open dot, and I want every number in between them. So those are your two different ways of graphing it. And last one here, it's x is bounded by the numbers a and b. A can't be a solution, so x has got to be bigger than a and less than or equal to b, since b is a solution. So on my graph, A gets a parenthesis, B gets a bracket, all the numbers in between. In other words, open circle, closed circle. All right, let's find the length of the interval -1, 1. So if we're thinking about this on the graph, here's -1 and here's 1, and 0 would be in between it. This would be a bracket, and everything in between. It's an interval. So the length of this interval is how many units? Well, I know that it's 1, 2 units, but there's a mathematical way of finding it. You could take the absolute value of your A minus your B or your B minus your A. It doesn't matter which, since it's absolute value. So if I take -1 minus 1 absolute value, I'm getting the absolute value of -2, which is just 2. So the length of this interval is 2 units, and I could have counted that if I wanted. Find the length of the interval 5, 13, with 5 being a bracket and 13 being a parentheses. How many units am I counting over here? Well, if you didn't want to draw a number line, you want to do the absolute value way, you could take 5 minus 13, and you know that's the absolute value of -7, and the absolute value is always positive, so 7 is the length of this interval. And the last one, -3, 0. You can either count, or you can take -3 minus 0 absolute value. The absolute value of -3 is +3. So lengths of intervals are going to be one type of web-assigned question. Those were all bounded. Next would be unbounded, where nothing is blocking it. See how these number lines were always in between and my endpoints were blocking it from extending forever? Well, unbounded can extend forever, either in one direction or both. So let's look at these different types. I have a number a, infinity. So it's bounded on a and unbounded on infinity. So my inequality are those numbers that are bigger than a and going on forever. So this isn't going to be a compound inequality. Notice how these inequalities were all compound. That's when you have two numbers. Here I only have one number. So my solutions to x are going to be those that are bigger than or equal to a. Okay, and think about this on terms of a number line. If you have a just anywhere here, I have a bracket, so I know that a is included as part of my solution, and this goes on to infinity, a on upwards. So there's nothing bounding it. This arrow shows that my solution could be 1,572,000. Okay, it goes on forever. Any number higher than a here, whatever a is. The other way you could do it, remember, is you could do a closed circle with an arrow, because bracket means closed circle. Okay, so this interval type is open here when I have parentheses on both ends. So that means that I still want numbers bigger than a, but this time a can't be a solution. So I want numbers x that are greater than a, not greater than or equal to, because a is not included as part of the solution. So when I go to graph it, I can either use a parenthesis and an arrow showing it goes on to infinity, or an open circle and an arrow showing it goes on to infinity. And the next one, -infinity, b. So that's telling you where your solutions are, anywhere from negative infinity up to b. So your solutions for x have to be those numbers that are less than or equal to b, because b is included as a solution. Your solutions go less than b and all the way to infinity, negative infinity, sorry. So on your number line, we want to show that b is included as a solution, so we put a bracket at b, and this arrow goes on to negative infinity. We could have also done a closed circle backwards to negative infinity. Those on the red here, I'm graphing the solutions. Any one of these numbers could work for this notation or inequality. Okay, again, I have another open interval, and the solutions have to be those numbers that are less than b. Numbers less than b are fitting in this notation. They're fitting in this interval. So on the graph, I'm going to use a parenthesis at b and showing that it goes backwards to negative infinity, or you could use an open circle. Remember, we're graphing the solutions to this inequality here. And the last one is the entire real number line being graphed. Okay, because if you think about it, if you're trying to pick any number from negative infinity to infinity, that's your entire number line. So you're just going to show one big long red arrow extending forever in both directions. Okay, this has infinitely many solutions. All right, we're going to be sketching the graphs of each inequality. So something I want you to keep in mind is whether it's a bounded interval or an unbounded interval. And how do I know? Well, if it's a compound inequality, this is going to be bounded. So the top two are compound. That means there's two inequality symbols in one. And these aren't compound, so they're going to be unbounded. All right, so sketching graphs here. And we can use the notes that we just took, or we can think about it logically. X stands for my solutions. So my solutions, my blue arrow that I'm about to draw, needs to be numbers that are greater than -3 and numbers that are less than 1. Okay, so I have two endpoints, -3 and 1. And I want to show in between there. Well, the less than symbol, you can either do an open circle, and the less than or equal to symbol, you could do a closed circle. And then you're connecting all of the points in between. The other thing you can do is an open circle is the same as a parenthesis. So you could put a parenthesis here, and a closed circle is the same as a bracket. And then you can connect the two to show all of the solutions are those in between this interval. Over here again, I have my two endpoints, 0 and 2. The solutions are those numbers that are bigger than 0, so this way, and less than 2, so this way. So I'm going to end up highlighting everything in between those two, but I need to make sure that my brackets or parentheses are correct. So neither of these are an or equal to. That means they're both parentheses, and I can connect in between, or I could do both open circles and connect in between. Either one will work on WebAssign. All right, part C is an unbounded interval, so that means it's going to be going on to infinity. Remember, whenever you're reading an inequality, to read the letter first. So this is x is greater than -3. You can write it oppositely as well if you'd like, as long as this alligator mouth is opening towards x in both of them. That means the same thing. X is greater than -3. Okay, so I have one endpoint, -3. You could plot 0 on here if you'd like, just for a point of reference. But this is saying that my solutions, my numbers, x, anything I plug in for x has got to be a number that's greater than -3. So I'm going to represent all of those numbers with an arrow to the right, because all of these numbers over here are bigger than -3. Now I just need to make sure I have an open or closed circle based on which type of symbol I have. If it's not an or equal to, it gets an open circle. That's the same thing as putting a parentheses here and drawing an arrow showing it goes on to infinity. On part D, the last one, it says x is less than or equal to 2. So I have one endpoint, 2, and I can put 0 on here as a point of reference. Less than or equal to means closed circle. Now I need to decide which way my arrow is going. My solutions need to be the numbers less than 2. So anything I plug in here has to be a number less than 2. So I know those numbers are off to the left. I could also do it with a bracket because 2 can be a solution and an arrow pointing to the left. So the difference is -3 can't be a solution over here because if I plug in -3, it's not going to be greater than -3. But if I plug in 2 over here, 2 is less than or equal to 2. So that's why I have a closed circle. 2 can be a solution. Sometimes we're going to have to solve a linear inequality before we graph it though. These are already solved for x. X was by itself in all 4 of these. However, here we need to get x by itself, then graph its solution. Okay, and then it wants us to write our solution in interval notation. So not only do we need to graph it, but write it as an interval. Remember that interval notation? You can either write it this way, in the interval notation way, or as an inequality. So we want to make sure that we hit both of those on WebAssign. So if I'm going to get x by itself, you can treat this as an equal sign. However, it's not, so don't get confused on that. But I need to subtract 6 on both sides. That way these would zero out. And then I'm left with x, drop down my less than symbol, 9 minus 6 is 3. Okay, so I have the inequality. Let's try to graph it. I have 1 endpoint 3, so I know it's an unbounded. It means it's going to go on for infinity in some direction. It's an open circle or a parentheses. And I know that the solutions x, numbers I have to plug in, need to be less than 3. So those numbers are off to the left over here. Or you could do a parenthesis and off to the left. Either one would work or be fine. Interval notation, you could go back and check your notes. But basically we have a parenthesis at 3 and it goes back to negative infinity. And infinity is always going to get a parenthesis. Okay, so this is showing you the solutions to this graph. Never put a bracket on infinity. We can't bound infinity on either direction. It goes on forever. This one, I again have to solve for x, so I'm going to first distribute my 3. Oops, 3x plus 3. Drop down my symbol and my 7x minus 3. Now I'm going to solve by subtracting 3x. Remember, I can only combine x's with other x's. So 4x minus 3 is greater than 3. Add 3 on both sides. And then divide by 4. And I get x is greater than 6/4. In other words, if I simplify it, it'd be 3/2. You can also think of it as 1 1/2. Either way, you have your answer. We need to graph it. So I have 1.5 here, or 3/2. And I know that my solutions are the numbers that are greater than 1.5. So those would be numbers off to the right. Greater than means I have an open circle. In other words, I could do a parenthesis. Okay. put this in interval notation. So one of my endpoints is 1.5 or 3 halves, and the other is positive infinity. Positive infinity always gets a parenthesis, and I put a parenthesis on 1.5. So this would be my interval notation. Okay, the last one, I'm going to pause the video. Actually, no, I'm not. This one's a little bit tricky. So let's say I subtract 8 on both sides, because I need to subtract first to cancel those. Drop down my negative 3x, drop down my less than or equal to symbol, and 20 minus 8 is 12. Next thing I need to do is divide by the number in front of x that's being multiplied, so dividing by a negative 3. This is something I want you to be cautious of. When you're dividing or multiplying on both sides of the equal sign, you need to flip the direction of your inequality symbol. So the inequality symbol was less than or equal to. Now my inequality symbol needs to be turned the other direction, greater than or equal to. So x is greater than or equal to negative 4. Okay, I'm not flipping anything else, just the direction my arrow is going. So on a number line, here I'm at negative 4. It's a less than or equal to, so I know it's a closed dot since it's or equal to. My solutions for x need to be bigger than or equal to negative 4. So the bigger than numbers are off to the right. I could also do a bracket and put it off to the right. Okay, so again, interval notation, one of my endpoints is negative 4, the other is at infinity, and I'm sorry, negative 4 does not get a parentheses. It's a closed circle because it's an or equal to, so it gets a bracket. Okay, so the important thing I want you to remember is when you are multiplying or dividing by a negative number on both sides, that's the key part, you need to flip the inequality symbol. Okay, and that concludes part 1 of the notes. We're going to have part 2 on a separate video to talk about some more important details when dealing with solving inequalities and graphing their solution sets.